Good day, everyone. Welcome in physical science. So before that, we'll be having a pre-test. So choose the letter of the best answer in each item and write it on a separate sheet of paper. So number one, which of the following is true of polar molecules? A. 1. Have high boiling point. 2. Have high melting point. 3. Low surface tension. 4. High vapor pressure. A. 1 only. B. 1 and 2 only. C. 2 and 3 only. D. 4 only. The answer is letter C. 2. Which of the following intermolecular forces of attraction, or IMFA, is arranged from strongest to weakest? A. H bonding dipole-dipole London forces. B. London forces dipole-dipole H bonding. C. Dipole-dipole London forces H bonding. D. High H bonding or London forces dipole-dipole. The answer is letter A. 3 to 6. For numbers 3 to 6, consider the choices below. A. Boiling point. B. Solubility. C. Viscosity. D. Vapor pressure. For number 3, refers to the resistance of a liquid to flow. 4 is temperature at which the liquid starts to boil. 5. Defined as the pressure exerted by a substance when in its gaseous state. 6. The ability of the substance to be dissolved in another substance to form a solution. The answer for number 3 is C, 4A, 5D, and 6B. 7. The following are examples of viscous substance except A. Blood, B. Honey, C. Vinegar, D. Syrup. The answer is C. 8. Which of the following is not true about water? A. Has high surface tension. B. Has high boiling point. C. Has low viscosity. D. Becomes denser when freezes. The answer is letter D. 9. Which of the following substance will most likely be miscible in water? A. Benzene. B. Ethyl alcohol. C. Carbon tetrachloride. D. Toluene. The answer is letter B. 10. Which of the following will dissolve in polar solvents? A. Nonpolar solvents and ionic compounds. B. Ionic compounds and polar covalent compounds. C. Nonpolar solvents and covalent compounds. D. All of the above. The answer is letter B. 11 to 15. So true or false, write T if the statement is true, otherwise write F. 11. The floating of ice on liquid water is an indication that ice has higher density than liquid water. The answer for 11 is F. 12. The volatility of a substance depends on its vapor pressure. The answer is T. 13. Alcohol is less volatile than vinegar. The answer is F. 14. Between water and carbon tetrachloride, water has higher boiling point. The answer is T. 15. Vapor pressure is inversely proportional to the strength of intermolecular forces present. The answer is F. Now, our topic for this day is properties of molecules based on its polarity. Now for the objectives. So number 1, define solubility, miscibility, and polarity. 2, identify the different types of intermolecular forces of attraction. 3, explain how polarity of molecules related to its properties. From the previous lesson, you've learned how to determine the polarity of bonds using concept of electronegativity. Also, you learned that polarity of molecules is affected by both polarity of bonds and its molecular shape of geometry. Let us have some warm-up exercise for our nerve cells before we proceed to the presentation of our lesson. You will learn or you will perform a simple activity that will help you recall some basic concepts related to polarity of molecules. Have some fun! Now, for our activity, word cryptogram. So directions. Unscrabble the letters by placing the correct letter sequence in shaded boxes. To come up with the correct answer from each number, use the numbered boxes to complete the answer to the riddle below. So number 1, 2 and 3, number 4, 5 and 6, and we have the riddle. It shows the three-dimensional arrangement of bonding groups of atoms around the central atom. After answering the riddle, so answer this. Can you define the following word terms that you have decoded? Now, the answer for this activity are number 1, molecule, number 2, polar band, 3, lone pair, 4, non-polar band, 5, electronegativity, 6, atom, and for the riddle, molecular geometry. Analyze the lyrics of the song, Tubig at Langis, and answer the question below. Tubig at langis, ang katayuan nate yan ang kawangis. Pilitin mang magsamay may mahapis. Ganyang-ganyan tayong dalawa, ang panuntunay magkaiba. Langis at tubig, di mapagsama ng tunay mang pag-ibig. Hinanakit ang siyang laging mananay. Mahal na mahal man kita, may mahal ka namang iba. Tubig at langis, idarang man sa init, di rin tatamis. Dahil ang halo'y luhat pag-iinagbis. Ang kirot ay di maalis kung labis. Bakit na naig ang dusa sa ligaya sa ating daigdig? May dasal ba akong hindi niya narinig? Papel natin sa pag-ibig, ako'y langis, ika'y tubig. Bakit na naig ang dusa sa ligaya sa ating daigdig? May dasal ba akong hindi niya narinig? Papel natin sa pag-ibig, ako'y langis, ika'y tubig. What is the message of the song? If you add oil to the water, what will happen? Will it create a single homogeneous phase, or will it form two layers, and why? Why do you think water and oil cannot be mixed, even when heated? Support your answer. Now, polarity, solubility, and miscibility. One of the practical applications of polarity of molecule in real life scenario is manifested on the solubility and miscibility of substance to form solution. Solubility is defined as ability of solid substance to be dissolved in a given amount of solvent, while miscibility is the ability of the two liquids to combine or mix in all proportions, creating a homogeneous mixture. The general rule to remember about the solubility and miscibility of molecular compounds can be summarized in phrase like dissolves like or like mixes with like. This means that polar substance will only be dissolved or mixed with polar substances, while nonpolar substances will be dissoluble or miscible with another nonpolar substance. Try this exercise below in order to assess how much you have understood the solubility and miscibility rule of substance in relation to their polarity. Which of the following substances below will most likely mix with each other? Polar A, water and chloroform. Polar B, benzene and chloroform. Polar C, water and vinegar. Polar D, acetone and toluene. Polar E, carbon tetrachloride and water. Okay, just write your answer uh, in your notebook or a plain sheet of paper. What chemistry concept did you use in answering the question above? If you answered polarity of molecules, then you are on the right track. Great job! Benzene and chloroform are both nonpolar compounds, while water and vinegar are both polar compounds. Thus, they are miscible to each other. However, the rest is a combination of polar and non-polar molecules and therefore will not mix and instead will form two layers even if shaken or carefully stirred. Bond strength, physical properties of covalent compounds. From the previous lesson, you learned that intramolecular forces of attraction, the attractive forces that binds atoms together. In this module, you will learn another type of attractive force, the intermolecular forces of attraction or the IMFA, which exists between molecules. In this lesson, we will not discuss IMFA in so much detail because it will tackle in the next lesson. We will just focus on the following salient features of IMFA and its effect on physical properties of covalent compounds. 1. There are several types of IMFA, and below there are arranged from strongest to weakest. Ion dipole, H bonding, dipole-dipole, dipole-induced dipole, London forces of attraction. 2. The strength of IMFA greatly affects the physical properties of substances, such as boiling point, melting point, and vapor pressure, surface tension, and etc. Below, or before we move further, try to perform the exercise below to test your ability to analyze concepts and principles that you have learned from discussion. Put a check to those properties applicable for polar molecule. So we have number 1, high boiling point; 2, low boiling point; 3, high melting point; 4, low melting point; 5, high volatility; 6, low volatility; 7, high vapor pressure; 8, low vapor pressure; 9, high surface tension; 10, low surface tension; 11, H bonding and dipole-dipole present; 12, London dispersion is present. How well did you perform in this exercise? From the above discussion, you have learned that there are several types of IMFA and their relative strength as compared to other types. Strong intermolecular forces tend to yield solids and liquids, while weak intermolecular forces favor formation of gases. Table 1 shows a comparison of various types of IMFA, while Table 2 shows the physical properties of polar and nonpolar molecules affected by the type of IMFA present. So we have here the summary types of intermolecular forces of attraction. So we have the type of IMFA, interacting substance, and for examples. For the ion dipole, interacting substance is the ion or cation or an ion and a polar molecule. For examples, for sodium chloride dissolved in water, calcium, and phosphorus chloride. So hydrogen bonding is the another type of IMFA. So interacting substance, polar molecules containing hydrogen chemically bonded to a small and highly electronegative nonmetal atoms such as nitrogen, oxygen, and fluorine. We have examples, we have water, ammonia, and methyl alcohol. Another one is dipole-dipole. So we have polar molecules, and we have metal fluoride and hydrogen sulfide and hydrogen chloride. We have dipole-induced dipole. We have polar and non-polar molecules, and we have example is hydrogen iodide and methane. And of course, we have the London forces, all substance and solely for nonpolar molecules and noble gases. We have oxygen gas, nitrogen gas, helium gas, and bromine gas. Table 2, gel properties of polar and nonpolar molecules. So we have polar molecules and nonpolar molecules. So we have amphitype, H bonding, and dipole-dipole. So we have here nonpolar, London dispersion, exists as solids or liquid, while the London dispersion exists as gases at room temperature. And we have here high boiling point, another one is low boiling point, high melting point, we have low melting point, high surface tension, we have low surface tension for the London dispersion, low vapor pressure, then high uh, vapor pressure in London dispersion. In H bonding and dipole, we have low vapor pressure, but in London dispersion, we have high vapor pressure. And hydrogen bonding and dipole-dipole, low volatility, but the other one is high volatility, soluble in water, and the other one is insoluble in water. Let us define the physical properties of substance. The array, boiling point, temperature at which the vapor pressure and atmospheric pressure of a liquid substance are equal. Melting point, temperature at which solid becomes liquid. At this point, the solid and liquid phases exist in equilibrium. Surface tension. So energy needed to increase the surface area by a unit amount. Viscosity, so the resistance of a liquid to flow. Vapor pressure, pressure exerted by a substance in its gaseous state. Volatility, measure the rate at which a substance vaporizes, or this what we will change from liquid to gas. In the simplest sense, boiling point, melting point, viscosity, and surface tension increases as the strength of internal force increases. On the other hand, vapor pressure and volatility decrease with increasing strength of IMFA. London dispersion forces increase as molecular mass of the substance increases. Now, for our activities for this day, we have activity one, strength of IMFA and physical properties of quantum compounds. For each pair of the molecules, identify the one with the higher boiling point, that will be the BP, melting point, MP, viscosity is V, surface tension is ST, and vapor pressure is VP, and briefly explain your choice. So this is it. Fill in the BP, MP, V, ST, VP based on these illustrations and diagrams. Activity 2, so number 1, distinguish intramolecular forces of attraction and intermolecular forces of attraction. 2, we have in your own words explain the solubility rule for polar and nonpolar substances. 3, compare and contrast polar and nonpolar molecules based on their physical properties. 4, what relationship can you derive between the strength of IMFA and the physical properties of covalent molecules? For activity 3, A, using the concept of band polarity and solubility, explain why water and vinegar are miscible, but vinegar and oil are immiscible. B, using the concept of intermolecular forces of attraction, explain why water melts at room temperature but solidifies when refrigerated. C, explain the importance of polarity molecules to biological processes such as in the structure of proteins and phospholipids. Now for the assessment, so choose the letter of the best answer. Write the chosen letter on a separate sheet of paper. For number 1, which of the following MFAs is considered as the weakest? A, hydrogen bonding. B, ion dipole. C, dipole-dipole. D, London forces. 2, the boiling point of water is greater than the dihydrogen sulfide because of A, dipole-dipole bond, B, H bonding, C, London dispersion, D, ion dipole. 3. Which of the following substance will dissolve most likely in water? A, oil, B, carbon tetrachloride, C, vinegar, D, hexane. 4. Which of the following molecules has high melting point? A, CHCl3, B, CCl4, C, BCl3, D, BeCl2. 5. Blank refers to the energy required to increase the surface area by a unit amount. A, viscosity, B, surface tension, C, vapor pressure, D, density. 6. Which of the following statement is true about nonpolar molecules? A, high boiling point, B, high melting point, C, low surface tension, D, low vapor pressure. 7. Which of the following substance is miscible in hexane? A, acetone, B, vinegar, C, chloroform, D, methanol. 8. The following are intermolecular forces of attraction except A, hydrogen bond, B, dipole-dipole, C, covalent bond, D, London forces. 9. Which of the following properties has indirect relationship with the strength of IMFA? A, boiling point, B, melting point, C, surface tension, D, vapor pressure. 10. In which of the following statements would molecular iodine be most soluble? A, vinegar, C, ethyl alcohol, B, water, D, carbon tetrachloride. For 11 to 15, true or false, write T if the statement is true, otherwise write F. 11. Hydrogen bonds are broken when ice melts. 12. Molecules with high hydrogen bonds have higher boiling point than molecules with dipole-dipole bond. 13. In covalent molecules, vapor pressure decreases with decreasing strength of intermolecular forces. 14. When the attractive forces holding particles together are greater, you have to get it to a higher temperature to break those forces, so the melting point is higher. 15. The strength of dispersion or London forces tends to increase with increased molecular weight. Now for our answer, number 1 is letter D, 2B, 3C, 4A, 5B, 6C, 7C, 8C, 9D, 10D, 11F, 12T, 13F, 14T, and 15F. For our additional activities, 1. Briefly explain why water is oftentimes called the universal solvent. 2. Using the concept of IMFA, account for the difference in boiling point and melting point of the following molecular substance. So we have the substance, boiling point, and melting point. Thank you for listening and have a good day, everyone.